Okay, so in part 2, we're taking a look at compositions and inverses. I know at the top it just says function composition, but you can see in problem number 13, there are some inverses involved, so we'll talk about that when we get there. So the first problem and the second problem, number 11 and number 12, they kind of look the same. They both are composing f and g, but remember that when we do function composition, the order does matter. So we're going to actually do f of g of x, and we're going to get a different answer than if we did it the other way around. So I'm going to take the f function, and I'm going to plug in g of x, which is this 4x squared minus 2x. So I'm going to say I actually want to do, plug in 4x squared minus 2x into the f function. So the f function is 2x minus 1, so I'm going to say this is 2 times 4x squared minus 2x. Okay, this is pretty straightforward. I'm just going to distribute and I'm done. Oh, let me put minus 1. Okay, so 2x minus 1. So I'm going to say this is 8x squared minus 4x minus 1. Done. That's all I have to do for that problem. Again, if they don't tell me a specific value to plug in for x, my answer should be an expression, and that's what happened here. Okay, so I'm going to do the same thing for the second one. I'm going to go to the g function, and I'm going to plug in f of x. So this is g of 2x minus 1. Okay, this one's going to be a little bit more work because the g function asks us to square x, and that takes us a little bit more effort. Okay, so I'm going to say this is now 4 times 2x minus 1 squared minus 2 times 2x minus 1. So I have to square 2x minus 1, which again I'll let you do by foiling 2x minus 1 times 2x minus 1. It comes out to be 4x squared minus 4x plus 1. And I need to distribute this negative 2 into the second polynomial, which is minus 4x plus 2. Okay, so I'm almost done. I need to distribute the 4 into the first polynomial. That's now 16x squared minus 16x plus 4. And then I have this minus 4x plus 2 from the second part. Now I can just combine like terms, and it's going to look like 16x squared minus 20x plus 6. And that would be my final expression. So if you notice, f of g of x gave me a completely different answer than g of f of x. So be careful when you're plugging in that the order does matter, and that's going to make a difference. Okay. So our second problem is asking us to do actually almost the same thing that number 12 is. This says g of f of x, which means take f of x, plug it into g. Okay. This one's actually saying do g of f inverse of x. So this -1 symbol tells us to take the inverse of f before we plug it into g. So if you remember, we had talked about when what order to do things. We said let's do composition last. Let's do all of our inverses first. Then if there's any operations, do those, and then last do your composition. So before I can plug into g, I actually want to come off to the side here and say we need to do f inverse of x. That is going to be, let me squeeze in a little x there. Okay, we actually need to say let's go to the f function, switch the x and the y, so it'll look like x equals 2y minus 1. Right, and then we're going to just solve this for y again. So I need to add the 1 over. Now it looks like x plus 1. Okay, and divide both sides by 2. It's going to look like y equals x plus 1 over 2. And I would say the inverse of f, which is what this is asking for, is x plus 1 over 2. So I'm actually going to go to the g function, and I'm going to plug in x plus 1 over 2. Okay, so let's bring that down. So I'm going to say g function says do 4 times, I'm plugging in f inverse now, so I'm going to plug this expression in, x plus 1 over 2, okay, squared. So that's going to be a little tricky. We'll talk about that in a second. Minus 2 times x plus 1 over 2. Okay. So I need to deal with squaring a fraction. So when I'm squaring a fraction, this is the first thing we're going to deal with right here. I need to square the top and square the bottom. So the bottom's pretty straightforward. It's just 2 squared, 4. Okay. When I do x plus 1 squared, that is x plus 1 times x plus 1. Well, x plus 1 times x plus 1 is x squared plus 2x plus 1. Right? So again, you can come off to the side if you want. If you want to do x plus 1 times x plus 1 and find out what that comes out to be, that's where I'm getting this answer from. Okay, so I'm going to get rid of that. And we are going to look at the rest of the problem now. So that's the squaring of x plus 1 over 2. This all needs to be multiplied by 4. Okay, and then I'm going to distribute the 2 into the second one to show you what it's going to look like. So remember, when we multiply together and there's a fraction involved, which is what this expression is, we say this is over 1. We multiply the numerators and we multiply the denominators. So this is going to look like, okay, and I'm going to bring in -2 in, so this is going to be, let's bring that out. So let's see what happens. We're going to say -2 times x, and -2 times 1 is going to be -2x plus, or I'm sorry, minus 1. Okay, let's get rid of that, and we're going to make that a -1. Okay, and on the bottom, I'm just going to do the 1 times 2, which is still 2. Okay, so now here's where you got to be careful with signs. Because I brought along the negative sign when I distributed inside, I'm going to make this big uh, operation between the fractions a plus. Okay, the negative sign got used up. If I just multiplied a 2 into both of these, I could have left that as a minus sign, but I just got to be careful that because I distributed the negative, it's not going to be sitting out in front of the fraction anymore. Okay, so for this first polynomial, I can actually do the same thing. This is over 1 as well, which means that 4 is only going to be distributed into the numerator. So it's going to become 4x squared plus 8x plus 4. The bottom is not going to get the 4 because I have a 1 on the bottom to multiply with that. So it looks like that. Okay, and then this one's going to be negative 2x minus 1 over 2. Okay, so we're almost done. We just have to put this together, and here's our problem. I can't add together two fractions, and that's what these two green expressions are. They are both fractions, and I can only add them together if they have common denominators. So the first one I'm going to leave alone. I'm just going to bring it down. Okay. The second one, though, I need to change so it has the same denominator as the first one, and I'm going to do that by multiplying the top and the bottom by 2. So now the bottom, I can say, has a 4 on it. Good, there's my common denominator. The top is going to become negative 4x minus 2. Okay, not minus 4. Okay, minus 2. Okay, and now I can combine like terms. So here's my final answer. 4x squared, adding that together. I don't see any other x squared, so my numerator is just going to have a 4x squared. Okay, 8x plus negative 4x. Well, that's 4x. Okay, 4 plus negative 2. Well, that looks like it's going to be a 2. Okay, so I'm going to say now this is going to look like over 4. Okay, my final answer. The only thing that I can do with this is a good answer, but it can be simplified a little bit. All of these coefficients have 2's in them, so I can divide everything by 2 and reduce a little bit and say this is going to be 2x squared plus 2x plus 1 all over 2. And I would say this is going to be as simple as I can get my final answer. Okay, so that one's got a lot of work involved because there was a fraction after I took the inverse, and when I square fractions, there's some work involved with that with your fraction operation. So be careful with that one. Okay. Problem number 14 is a lot more straightforward. So this one's saying let's do h of j of 10. So again, what that means is we're going to start off with the h or the j function, plug in a 10. After I have the answer to that, I'm going to plug that into h. So that's the idea of compositions. Take the output of j, plug it into h. So I'm going to go to the j function, and I'm going to say 2 times 10. Okay, so here's j of 10. Okay, j of 10 is going to be 2 times 10 over 5. Well, that looks like 20 over 5, which is 4. So this is really just saying do h of 4. Well, h of 4 is going to be 2 times 4 minus 4 squared. All right, so that looks like 8 minus 16, which is negative 8. And that would be my final answer. So that one was way more straightforward because of the numbers. All right, we didn't have any inverses involved. So let's keep going. Okay, this one's got some more function composition to it, right? So we're going to have some operations showing up and some addition and subtraction, some double compositions, or like problem number 16. So let's go again. Problem number 15. It is asking us to do f plus f. Once I have that answer, plug that answer into g. Well, f plus f is going to be 2x minus 1. That's what f is, plus another 2x minus 1. Okay? So that looks like 4x minus 2. So they're asking us to take 4x minus 2, plug that into g. So that's going to look like 4 times 4x minus 2 squared minus 2 times 4x minus 2. Okay? So I'm going to take this expression. Okay, this needs a little parentheses around it. Okay, and I need to square 4x minus 2, which again, I'll let you do the foiling if you want to see it happen. And it's going to look like 16x squared minus 16x, okay, plus 4. And that is the 4x minus 2 squared. And then I'm going to distribute the negative 2 into both of these. That's going to look like minus 8x plus 4. Okay, I can do distributing of the 4. That's 64x squared minus 64x plus 16, and then I have these last two expressions that can come along. Okay, and now I can just combine like terms. So I'm going to say 64x squared is my only x squared. Okay, negative 64 minus 8 looks like negative 72x. 16 plus 4 is 20. So I would say f plus f composed into g of x is going to be 64x squared minus 72x plus 20. Okay, next problem. J is asking us to, I'm sorry, this is saying F composed with G composed with J of 5. So that means take the 5, plug it into J, get that answer, plug it into G, get that answer, plug it into F. So this is going to look like, let's come over here and do J of 5. Okay, J of 5 is going to be 2 times 5 over 5. Okay, that's 10 over 5, which is 2. So I'm going to say this is going to be G composed with 2. Let me get that 4 out of the way. We want a 2 there, right? So I'm going to say I got a 2 to come out of J, so I'm going to plug a 2 into G and find out what comes out. Well, that's going to be 4 times, okay, this is going to 2 squared, which is 4, times 4 is 16. 16 minus 4 is 12. Okay, so when I plug a 2 into G, it looks like I get a 12 to come back out. Okay, so I'm saying take that answer, plug it into F. So this is really F of 12. Okay, F of 12 says do 2 times 12 minus 1. Okay, so this says 24 minus 1. This is going to be F of 12, 23. That's my final answer. Okay, so I'm going to say that the final answer for F of G of J of 5 is 23. Okay, so let's move down and take a look at H of X composed with G over F of X. Right, so this is again saying let's simplify G over F first, get the answer to that, and that answer is going to get plugged into H. Okay, so I'm going to start off by saying let's do G. Well, my G function is this one right here. So I'm going to come up to the top here and factor this. It looks like it's just got a GCF, so I'm going to say 2x times 2x minus 1. That's all I can do with that. All right, pull out a GCF. So when I come down here to do G over F, I'm going to do 2x times 2x minus 1. Okay, and then F is just a 2x minus 1. Okay, so I'm going to say that the final answer to this, when I cross off the common 2x minus 1s, this is just 2x. Okay, I'm going to take the 2x and plug it into H of X. That's what it's asking me to do. Take the answer to this second one, plug it into the first one. So H of X is 2x minus x squared. So I'm going to say this is going to be 2 times 2x minus, and it was minus just regular x squared, which is going to be 2x squared. Okay, so I just need to simplify this expression, and I'm done almost. So I'm going to say 4x minus 4x squared. That's finished. That's as simplified as I can get. 2x times 2x is 2x squared, or it's 4x squared. Okay, here's the catch. There is a domain restriction right here. Okay, I am not allowed to have 1/2 as an x value. If you set 2x minus 1 equal to 0 and you solve it, you find out that 1/2 is a domain restriction. Because division showed up in this problem anywhere, I have a domain restriction. I'm going to say x is not allowed to be equal to 1 over 2. Okay, so make sure that you put those domain restrictions in. Even though this is a part of a bigger composition problem, you still need to have domain restrictions. Okay, so last problem looks like G over H, which means let's multiply together G and H. I'm sorry, G times H, which means multiply together G and H. So I'm going to say 4x squared minus 2x times H, which is 2x minus x squared. So this is just a big distributing problem. Okay, this is not a composition problem, so be careful. This is not saying take H, plug it into G. Notice the open circles here. This does not have an open circle. We're just multiplying these expressions together. Okay, so I'm going to say this is 4x squared times 2x. Well, that's 8x to the third. Okay, 4 times 2 gives me an 8. So I'm going to say 8x to the third. Okay, 4x squared times negative x squared looks like negative 4x to the fourth. Negative 2x times 2x would be negative 4x squared. Negative 2x times negative x squared is going to give me a positive 2x cubed. Okay, so I have one little combining like terms. I'm going to put this in standard form as I go. Negative 4x to the fourth is first. Okay, I have an 8x squared plus 2x. I'm sorry, 8x cubed plus 2x cubed, which is 10x cubed. And then I have this minus 4x squared, which does not have any like terms. So I'd say my final answer, negative 4x to the fourth plus 10x cubed plus, minus 4x squared. Okay, so once again, I'm going to stop the video. We're going to do this in 3 parts, so none of them are too long. Okay, this deals with all of the composition problems. We'll do all the rest of the material in the third and final video.